ChatGPT goes around the world and now is finally available as an API. AI can now read your brain, and Meta's llama's weights leak in a hilarious fashion. Welcome to ML News. I'm your host Yannick, and nice that you're here. Hello, welcome to ML News. First things first, it's GTC time. NVIDIA's GTC conference is happening in March 20 to 23rd, especially the keynote is happening on March 21st. So you should not miss this, not only because it's a very cool conference, it's completely free, you can attend all the sessions that you want, but also because if you do, you can win a graphics card. So you can win a really nice 4090 Ti signed by Jensen Huang. This is exclusive to only very few places, and I'm very happy that my channel is one of them. So go to yculture.com/GTC if you want to participate. Note that you do have to be in EMEA in order to do so. If you're not, you can still go to this website and I'll raffle out some merch. And to make this even more fleshy, I have interviewed the VP of Applied Deep Learning Research at NVIDIA, Bryan Catanzaro, and I'll post the interview with him at the end of this video. This is important because this person in large part decides what the future of hardware is going to be. NVIDIA does research themselves in order to estimate the trends going forward and in order to adjust their hardwares, their software, and so on to what they think will be the future. And Bryan is at the dead center of that thing. So whatever Bryan does and thinks and says and creates is probably going to have a very large impact on how the deep learning field evolves in the near future. So definitely worth a listen. As I said, the interview is at the end of this video, and now let's dive into the news. Greg Brockman tweets, ChatGPT API is now available. So the ChatGPT model that has been only available as a web interface, as a research preview, is now available in the OpenAI API, which means you can give them money in order to interact with ChatGPT in a programmatic way. It's a lot cheaper than the DaVinci models, the classic GPT-3 models, which we might infer it's probably a bit smaller than them, but who knows, maybe they've just gotten more efficient or they've determined that this pricing is better. In any case, it's about 10% the price of the large models. And not only is the ChatGPT model available, but they've also activated the Whisper model in their API. Now, Whisper is a model that they have previously given out open source. It is a model that takes in speech and transcribes that speech, and it does so very well. So now also that is available in their API. So it becomes easier and easier as a developer to interact with AI, to interact with these models. You don't have to know deep learning or frameworks anymore. I, for one, think it's a cool direction that a lot more of these APIs are offered. I obviously also think that OpenAI, with their big speech about democratizing and sharing and so on, is, what they say and what they do is 180 degrees apart from each other. But in principle, I think it's a good direction for developers that these things are generally available as APIs. On their blog, they have a few examples. For example, a Quizlet here is using it to automatically create quizzes about things that you might want to learn. So this is essentially a personalized tutor that's done via ChatGPT. So I believe that there's a lot of interesting applications, and certainly other people have believed that as well, because we're now seeing a ginormous flood of applications of everyone hooking into the ChatGPT API. And just saying how easy this is, Greg Boggs on Twitter has tweeted out, built a command line chatbot in Python with the ChatGPT API, 16 lines of code. I'm not sure anyone's ever shipped a more powerful dev tool than OpenAI. He's also released a blog post of how exactly he does that, and it's deceptively simple. All you do is you define this system parameter, and the system essentially says, you are a helpful assistant, or please pretend to be someone from the moon, something like this. Then you take turns in, providing messages. The model is called GPT 3.5 Turbo. Again, we're not sure if it's a smaller version of GPT-3, if it's just a faster version for hardware reasons. Nobody knows. But with a few API calls, with a few web calls, you can definitely just make a chatbot or make it do pretty much anything. So the blog post goes a bit over the changes that you have to make if you previously used the old OpenAI models and now want to switch to ChatGPT. I'll leave a link in the description. Also, OpenAI is moving more and more towards sort of the business world, away from the research world. They have new policies. So Sam Altman tweeted, data submitted to the OpenAI API is not used for training, and we have a new 30-day retention policy and are open to less on a case-by-case basis. We've also removed our pre-launch review and made our terms of service and usage policies more developer-friendly. So everything for OpenAI goes into the direction of essentially providing AI as a service, and much less, taking part in research. That is also evidenced by a leak that happened a few days earlier, which is called the OpenAI Foundry, which is essentially a system, at least as the screenshots here claim, where OpenAI essentially provides dedicated hardware, dedicated inference hardware to businesses. So you can go to OpenAI and you can give them some money. For example, here, if you want to do a 1-year commit to the DaVinci model with 32,000 token context, you just give them 1.5 million, easy peasy. And then you get a 1-year dedicated 600 units, instances, whatever that is. You get dedicated hardware for you, so no one else, can interfere with you. This is likely targeting businesses, probably larger businesses that have significant demands and constant demands for these types of workloads. And lastly, there is now a collaboration between OpenAI and Bain & Company, which is like a consulting shop, like a marketing consulting shop. And OpenAI brings their technology in order to make Bain & Company's business better. So you might know them, for example, from Coca-Cola. They say, with ChatGPT and DALL-E, we're helping Coca-Cola to augment its world-class brands, marketing, and consumer experiences in industry-leading ways. We're also using OpenAI technology to improve business operations and capabilities. Now it doesn't say anything, but they are very much talking about like very targeted ads, for example. So by using DALL-E or something like this and ChatGPT, you can make very targeted ads to individual users. Now, is every single one of these ads gonna come with a big fat disclaimer that was done by an AI? No? Who would have guessed? I'm sure Stanford is like shaking in their boats, writing lectures left and right. Yeah, I mean, it's a company, so that's fine. Don't wanna complain about this. However, at the same time, from the ground floor of the trading corners, they're now getting back on their horse, and here we are with a blog post planning for AGI and beyond. I want to say it's a bit of a fluff piece that just repeats again and again how much they want to benefit all of humanity, and it's essentially a justification for them not being what they set out to be at the beginning. At least part of it is. So they, for example, speak about how at the beginning they were, not expecting that scaling was so important. For example, this side note here, we didn't expect scaling to be as important as it turned out to be. When we realized it was going to be critical, we also realized our original structure wasn't going to work. We simply wouldn't be able to raise enough money to accomplish our mission as a non-profit, and we came up with a new structure. They also said, as another example, we now believe we were wrong in our original thinking about openness and have pivoted from thinking we should release everything to thinking that we should figure out how to safely share access and benefits of the system. We still believe the benefits of what is happening are huge and yada, yada, yada. Essentially, as I said, it's a justification for the fact that they're not open anymore, not non-profit anymore. They're very much making money, which again is fine for a company, but don't at the same time talk to me about openness and sharing and so on. This is very much, we're going to develop this, we're going to make money off of it, and we tell you what's good for you. They claim to be still open in other ways, yet they don't. No one knows how, what exactly is running when you do a GPT-3 inference or a ChatGPT inference. No one knows how the supposed good safety filters of that thing work. No one knows, what training data exactly went into these models. None of these things are known, and none of these things will probably ever be known in detail. So it's very much the opposite of open, and it's very much not sharing it with everyone and maximizing the benefit of humanity. They're couching this in a language of like safety and the substantial risks of AGI. This is a Silicon Valley company, right? So I'm totally ready to believe that someone is delusional enough to think that they are on the doorsteps of AGI and that the risk is so big and they just have to do something. On the other hand, isn't it just like very convenient that that's also like the way that your company makes the most money and that your company can retain as much stuff as possible, even though you set out to do the exact opposite? It just seems like a lot of convenience coming together. That's all I'm saying. Again, given that it's a Silicon Valley company, it's totally possible that people actually believe that. In any case, you may read this. There's not too much information in there, but yeah, that's that. Now, with the success of ChatGPT, the influencers come. And I know, glass houses, blah, blah, blah. But certainly everyone is giving tips left and right of how ChatGPT works and, what to do. Oh, you can earn 300,000 by prompt engineering. Oh, this odd ChatGPT skill pays 335,000 a year. Create a course online using 100% AI. Like, you just type into ChatGPT, make me a course, and then you make a course. Why wouldn't someone just go to ChatGPT themselves if you just make the course using ChatGPT? ChatGPT is supreme, but it has limitations. Here are 10 must-know AI tools to work smarter, not harder in 2023. It's always like you just change the words of these influencer people, and then they always have a Substack or something where you subscribe. By the way, I have a Patreon. Just saying. Like, look, oh, this pen, you thought you knew how a pen worked, but no, you've been using pens wrong all your life. Here are 10 websites, 10 awesome tools to use your pen better in 2023. Ha ha ha. Follow my Substack. ChatGPT and Bard are phenomenal AI, but these 50 new websites to finish hours of work in minutes. I'm giving away a few premium accounts. Go, go, go. A thread. Oh, a thread. Wow, that's something new. Never seen that on Twitter. The awesome ChatGPT prompts repo is now available. 50 awesome ChatGPT prompts. Influencers. Now, of course, like all of this is probably like useful information to someone, so I don't want to dump on this, but there's definitely an industry of sort of making clout off of the hype now. And again, glass houses, yeah, but I'm pretty sure I was here before ChatGPT existed. In any case, I actually welcome the additional attention. I feel it's cool that the world kind of is taking notice of what's going on right here, except the European Union. The European Union is welcome to just not look and not listen, because it will just try to regulate everything. And that's not fun. But everyone else, welcome. Welcome to the field. There's definitely also good content. For example, this here is a free and open source course on prompting, communicating with artificial intelligence. You can just go there. You don't have to subscribe to a Substack. It's free and open source. If you want to get into prompting, this might be a resource. Learnprompting.org. Google researchers release a new model, a UL2, has been released a few weeks ago, but okay. UL2 has been released a few weeks ago, or months even. It's a 20 billion parameter model that has a very new, interesting training paradigm. And now they've taken that and tuned it in a Flan way. So Flan is a codename for models that have been instruction tuned in various fashions. There's always been Flan T5 beforehand and Flan other models, and now there is Flan UL2. So the checkpoints here are available on Hugging Face. You may go, you may download them, you may try them, and maybe they'll help you, especially if you have some sort of instruction following, task doing thing. So an example is this query right here. Answer the following question by reasoning step by step. The cafeteria had 23 apples, they used yada yada yada. So if you have some sort of task and you want a response, maybe this model is good to check out. Speaking of model checkpoints, the LLaMA weights have been leaked. Well, LLaMA, you'd have to go through this process of a form to apply to Meta, and they determine whether your heart is pure enough to really wield the LLaMA weights. They were only for research. Now they've been leaked, and the fun thing is a person has submitted a pull request to the LLaMA codebase, and the pull request, the change here, so there's a link to the Google form. The pull request changes that like to, or if you want to save your bandwidth, use this torrent link. So there's a magnet link for BitTorrent. First people said, well, this is one of the meta researchers who mistakenly sort of put that there and shouldn't have. You should only give that to people who actually filled out the form before. Yet it's, as far as I can tell, this person who made the pull request, Christopher King 42, is not a meta researcher, or I'm mistaken. Even if they are, do not trust this. PyTorch model files contain executable code. Only trust this once we have verifiable checksums of these files. I'm totally ready to believe that these are the correct weights, their size matches and so on, but it's very dangerous to just download them from somewhere. What's funny is the response of the community. So this is the request, and the bot, like the GitHub bot, is guiding them through the process. Like, hey, thank you for your pull request. Welcome to our community. And so they ask him to sign the license agreement. And then people just jump in and approve the changes. On GitHub, you can just go and review a pull request, right? So people jump in going, looks good to me. And so apparently Christoph signed the license. We can now accept your code. Thanks. So the comment section is going nuts. And on the right hand side, you see the reviewers with all kinds of approvals. And, you know, in general, people are very happy about this change. I love the internet. The internet is great. By the way, Open Assistant is going absolutely fantastic. The data we've collected so far is phenomenal, and we are continuing. We're also training the first models. We're all preparing to do V1 releases. Yeah, that's going well. If you don't know about this project yet, go to open-assistant.io, grab a task, play the assistant, and help us. Right, there's a new paper by researchers from Japan that's been accepted at CVPR, and it's literally reading your mind. Like literally. So on the top, you can see presented images to people, actual people, and then from an fMRI scan, the system can reconstruct these things at the bottom. So you'll see that they do match in sort of a little bit visually, but also like semantically a lot. So a snowboarder in the snow, a tower with a clock on it, so on. And it's relatively simple. So they have a training data set of people where they present images and measure their brain activity. And what they do is they simply train sort of encoders and decoders here from brain space to latent space of the Stable Diffusion model. So they don't train a big model to reconstruct these images. They just take Stable Diffusion and they assume that all the information you need to reconstruct images is already there. And they just need to train a little mapping from brain activity to the latent space of Stable Diffusion. And that works pretty well. And as you can see, you know, right here, it's quite fantastic. They have some hypotheses of which brain areas map to which parts. For example, the latent vector Z right here, or the conditioning vector C. Why are they called so similarly? See, the conditioning vector is usually that's the text vector in Stable Diffusion. So you take the different brain area signals, you learn a mapping from those to the latent vectors in the Stable Diffusion process, and then you just let it run. Yeah, it's pretty amazing how far we're coming. Not only is it amazing that we can sort of read people's thoughts, but it also, I think, tells a lot about like our models that we have might be not as far off as brains in terms of how they understand images and their contents, right? So for example, here you can see sky, and down here you can see sky, and one is sort of more or less cloudy, the other one is more bluish, and so on. It's sort of, but semantically it kind of matches, and that's what's fascinating to me. So it's not just that the colors are right, you know, the pixels are somehow, it's kind of matching semantically. That leads me to believe that we're sort of getting closer at understanding ourselves by training these models. And that's, by the way, also why I have quite a bit of hope for sort of the large language models. People always argue, oh, the large language models aren't intelligent, they don't understand anything, and so on. And in my mind, it's not a question of sort of what the large language models can't do, but the question is much more, are you as a human doing really that much more than sort of statistically interpolating your training data? Like, are you really doing that much more? I have my doubts that you are like that far ahead of something that just kind of does statistical, you know, look-alike inference of the training data. I think humans overestimate themselves a little bit in how smart they are. And here's another paper about brain mind reading, evidence of a predictive coding hierarchy in the human brain listening to speech. So again, we're dealing with fMRI images, as I think so, yes, or at least brain readings. Yes, fMRI images. And this time it's not people watching images, it's people listening to speech. At the same time, they take the same speech and feed it into language models, and they see sort of how far ahead the human brain must be predicting in order to really listen and understand that speech. And then they compare them to the language model. And they find a lot of evidence for what they call a predictive coding hierarchy, which means that the human brain very probably predicts not just at one time scale, like our language models currently do, but at multiple time scales. So different regions in the brain do predict the text at a different sort of frames and different granularities, and also hierarchically, which means that they first sort of predict what the general thing is that's coming up, and then they predict sort of the different elements, and only at the end they predict the individual tokens from this hierarchical information. A lot of evidence is being generated. Again, I think by training these models, we come closer and closer to understanding ourselves, and that's pretty cool. Now, understanding ourselves is good and well, but the robots aren't so well. Alphabet lays off hit trash sorting robots, right? It's Wired. So this is everyday robots. It's a section beneath Alphabet that was doing these kinds of robots that could do household tasks. They could go around, they have cameras. You could teach them stuff. They could, as you can see here, clean a table and so on. Now, this problem, it looks easy, but it is really, really, really hard for robots in the real world. You know, one of these chairs could be a bit different. The tables could be a bit different. There could be something in the way and so on. The robotics in the real world is really hard. And everyday robots has now been hit by the big tech layoff wave that's currently sweeping these large companies. So Denise Gamboa, Director of Marketing and Communications for Everyday Robots, says Everyday Robots will no longer be a separate project within Alphabet. Some of the technology and part of the team will be consolidated into existing robotics efforts within Google Research. So it's part layoff, part restructuring, but yeah, I think it just shows robotics is quite hard and maybe not as fruitful right now, but who knows what the future brings. Maybe just not as profitable. This is an article on the Hugging Face blog. It's Swift diffusers. So this is Stable Diffusion on Mac. So if you have like an M1 chip, you can get, or an M2 chip, you can get very fast Stable Diffusion by simply downloading this app from the App Store. Very cool. PyRibs is a library for quality diversity optimization. Quality diversity is a technique in sort of the forever learning space, in the space of, hey, let's train things without having objective functions or without having the single objective function. And this often leads to more robust results, more diverse results, and so on. And this is a library that supports that. So if you're in the space of lifelong learning, exploratory learning, evolutionary search, things like this, maybe check out this library. Rowan Chung tweets, the most disturbing AI website on the internet, upload a photo of a person and AI will find all of the images of that person across the internet. This is about a website called PimEyes, and you upload a photo and it uses facial recognition and it searches your face. I don't know. Is it good or bad that this exists and is accessible? Who knows? Like, you can do Google image search, right? You can do image reverse search. You can find a particular picture. You can classify pictures in Google image search. You can certainly search the internet for your exact name, right? In Google, you just quotes and you put your name. You can find yourself. So why is it that tragic if you can find an image of yourself? That I don't know. On the other hand, it does seem quite creepy. Of course, it is possible to do this because it's possible. It's pretty sure that all the governments are already doing it. So then you can also ask yourself, is it that bad that like a private company is doing it? So they offer you things like you can have alerts if a picture of you appears somewhere. You can also erase your picture. So this is very much like other PII erasure websites. They would go to external websites and kind of bully them to get rid of your picture. Well, bully them. They would use legal means in order for them to get rid of your picture and so on. I'm not sure what to think of this website. I'm not per se against it. This one here, there's an opt-out request, so you can opt out, but identity proof is required. Means you have to submit your passport if you want to opt out of this. That seems a bit shady. Like that seems, I'm not sure how else you would do it, but it does seem a bit shady that if I'm concerned about my privacy, I have to send my passport to some company for them not to allow others to invade my privacy. That's a bit fishy. That's all I'm saying. All right, the last helpful thing, Cacti is a framework for scalable, multitask, multi-scene visual imitation learning. This is a multi-step process, and the framework helps you in achieving all of these steps. So collect data. This is demonstrations for kind of robots and robotics. Then augment your data, compress that data, and at the end, train an agent on that data. So here's a bit of a video of robots doing cool things. I do think, I said before, robotics is really hard. I'm very happy that other companies aren't stopping their robotics efforts. Google isn't either, but I feel like robots are still a lot cooler than really smart chatbots. I know, a really smart chatbot might change a lot more lives than a single robot. I just think robots are cooler, and I'm very happy research is happening into that direction. Shout out to Sanyam Bhutani, who has used ControlNet and the PyTorch logo to do really awesome images. And these are really, really cool. And it does show how easy it is nowadays just to do AI art, just to be creative with these tools. I'm planning to do a bit of a dedicated video on just tools that exist, but the landscape changes so much. You wait a week and there are 3 new major tools out. Like this one, ControlNet, it's like blows your mind what it can do, where previously you'd have to have extremely serious Photoshop skills in order to achieve this. Yeah, shout out. These look amazing. All right, we're at the point where we go over to the interview with Bryan Catanzaro. Again, this is the VP of Applied Deep Learning Research at NVIDIA, and he's going to tell us a little bit about what NVIDIA is doing in research, what the plans for the future are, what their mission is, and what you can expect from his talk at GTC. Again, go to yculture.com/GTC in order to take part in the raffle and maybe win an awesome GPU and have a lot of fun attending GTC. I hope to see you there, and bye-bye.
My name is Bryan Catanzaro. It's an Italian name.
Catanzaro.
So you just pronounce it very like Latinate,
Yeah, so I wanted to ask you a little bit about NVIDIA and NVIDIA research specifically, because I always think of NVIDIA as, the graphics card manufacturer. So my question that I really had all my life, essentially I've known NVIDIA, is why does NVIDIA even do research? Why do we see cool papers coming out of NVIDIA? And I remember the first big one was like really scaling up GANs and making really beautiful images out of that. Why do you even do that? Why don't you just sell more cards and have others do it?
Well, NVIDIA is not about selling cards. NVIDIA is an accelerated computing company, which means that we're trying to build technology that allows people to solve problems that just could not be solved any other way. And we know that in order to do that, we have to optimize every part of the technology. That includes the chips, but also it includes the networking, it includes the systems the chips go into, it includes all the software, the frameworks, the compilers, the libraries, the applications, the algorithms. All of these things are connected, and they have to be optimized jointly in order to get the benefits of accelerated computing. Our business is not just to sell a chip. What we're trying to do is enable people to solve problems they couldn't do without accelerated computing. And so that means we have to understand the applications deeply, and that means we need to do research. One of the things that's challenging about being in the accelerated computing business is that we have to be extraordinarily focused on what we think the most important computational problems of the future are as we're creating this technology. Accelerated computing implies decelerated computing. We're going to focus on a few things that we think are the very most important computational problems, and we're going to push the limits. Every part of the computation, every part of the infrastructure is going to be optimized in order to solve that problem. And then the other stuff we're going to let go. We're not going to worry about that. We're going to let traditional systems, non-accelerated systems, take care of that. So the fundamental question of accelerated computing is, what are you going to accelerate? And so research helps figure that out. And I was able to be involved in that when I joined NVIDIA Research in 2008, so 15 years ago. I was the only person working on artificial intelligence. And I had the freedom to investigate what would it mean for artificial intelligence to run on the GPU. How could we make libraries for that? How could we accelerate AI on the GPU? And being involved in that project, I think, has been really good for me. I've had a lot of fun, and I think obviously NVIDIA has been able to focus so much on AI. But as many things happen at NVIDIA, it starts with an exploration. It starts with a question. It starts with research. And so NVIDIA research has been instrumental in a lot of different technologies that have been important to NVIDIA: ray tracing, artificial intelligence, the generative AI that you brought up, our work in GANs. All of this comes from our desire to better understand the most important computational work and then figure out how we can push that forward.
Would you say that's your mission statement, or do you have sort of an overarching demand from the company, like here is the one thing you should be doing? Or is it what you say? Is it push the frontiers so we know what's coming tomorrow?
Sometimes we talk about the mission of research being to lift the headlights of the company so that the company can see just a little bit farther into the future. I think also research provides a place to incubate ideas that we think are promising but aren't proven yet. We know as a company that the only constant is change. If you look at the kinds of workloads we've been accelerating over the years, there's been a ton of change. We know that the workloads of the future can't be the same as the workloads of the past because the applications of the future are different. And we also know that the value of accelerated computing is enabling people to solve new problems. It can't be just about retreading the problems of the past. If we just built systems, let's say, for example, that we're the fastest in the world at training ResNet 50, we just focused every bit of our might for accelerated computing on ResNet 50, then we would have missed generative AI, right? Because ResNet 50 isn't generative AI, it's a discriminative problem. You're just trying to classify an image. And so we know that the applications of the future are different from the applications of the past. We know that the choices about what applications are important are critical to NVIDIA's future. Because again, if we're trying to build accelerated computing, we have to know what to accelerate and what to not accelerate. And research is part of the way that NVIDIA decides how to answer these questions for itself. It's not the only way. I mean, there's people all over the company that are incredibly innovative and building awesome technology and have deep understandings of AI and where the future is going. It's not research's job to be sort of the only people thinking about the future. The whole company is thinking about the future. But research has, I think, a special ability to incubate things and to ask questions that maybe the company hasn't been asking yet.
So this question might seem a little bit cheesy, but Jensen Huang said that NVIDIA chooses to solve the hardest problem, not the easy, convenient ones, which plays a little bit into the role of what you're saying, right? Now, there is a way in which, leaders just say that because it sounds cool. But what do you understand? Like, how do you go about that, right? If I assume you take it seriously to solve the hardest problems, can you give us an example of that?
Well, I think one of the ways this manifests has to do with creating something new. I think NVIDIA is generally oriented to build something new rather than to enter into some battle, some zero-sum battle where somebody's going to win and somebody's going to lose. We love starting in a market that no one cares about yet, but that we have a lot of conviction in. And that's always going to be hard. It takes enormous conviction to go into a market that's worth $0 billion and plant, all of your energy and all of your focus on that market because you believe that in the future that's going to matter. And generally it's the case that if you're working in a space like that there's a ton of problems everywhere. If the problems were well understood, if they had already been solved, then there would already be tons of people working in that space. And so when Jensen says we focus on the hard problems, I think he's right. I think that is our culture at NVIDIA. And I think the reason that we do that is because we believe that's where the most interesting problems are, and we believe it's where we can add the most value.
Can you maybe give I guess we're talking about the future and recognizing future markets, recognizing what devices we need to build for the future. Can you give us a little bit of insight? Don't reveal any company secrets, but we had Stable Diffusion come along, we had ChatGPT come along, and what do you see? If I just could guess what the future is, it's bigger transformers. It's kind of boring. So I'm wondering, where do you see the future, the next few years?
It's such an interesting question. I mean, first of all, I have to say, bigger transformers are not boring to me. One of the reasons is that they just keep doing more and more amazing things. When the Transformer first came out, in 2017, and it had that famous title, "Attention is All You Need," it was kind of perceived as a joke, right? But nowadays, it doesn't feel quite so much like a joke. It's amazing. It's extraordinary. The BERT models of 2018 were incredible language models for the day. And yet the difference between a BERT model and a ChatGPT model over the past 5 years is extraordinary in the understanding of intelligence, in their ability to do problem solving. I think the thing that's so extraordinary right now about the large language models that we're seeing is that they actually are able to solve problems that they've never been trained to do. And we call that zero-shot reasoning. And that's extraordinarily valuable because it allows us to apply them to all sorts of new places. And so I think that, just as larger transformers, you could say the only difference between BERT and ChatGPT is that ChatGPT is trained on a lot more data with a little bit different training objective, but it's still just a much bigger transformer. I think in between ChatGPT and what we're going to see in the future 5 years from now is also going to be extraordinary change. I personally am going to bet that huge transformers are still going to stay part of that change because they just have proven themselves to be so flexible and useful. But I don't think that's not exciting. I mean, I'm totally excited about it. So I think there's going to be a proliferation of applications of this technology in new ways. Obviously, there's a lot of problems with ChatGPT. We love ChatGPT. It's so exciting. It's caught the industry's imagination. It's caught the public's imagination. And yet we know that it needs to be better at factual question answering. It needs to be better at using current information, perhaps including tools like web search or, the ability to write code in order to solve problems. I think that what we're going to see is a composition of these language models that really expand our capabilities to problem solve.
Before I forget and our time runs out, do you want to give us a little bit of a preview of your session at GTC? Here's your chance to tell people why they should come and watch.
Yeah. Well, this year at GTC, I'm giving a talk about generative AI and sort of explaining what it is, where it comes from, and where we think it's going. Obviously, generative AI is having a big moment. Mark Zuckerberg just announced that Facebook's building a new top-level product group focused on generative AI. Microsoft has pivoted so much of their strategy to incorporate generative AI in Bing and other products, and I think that we're seeing this incredible interest in generative AI technologies across the industry. So the question is, how should we understand that? What is this technology? How's it built? What are its strengths? What are its current limitations? Where do we think it's going? And what does it mean for us and for the technology industry? And so that's what I'm going to be talking about.
You just you said you believe transformers will sort of stay with us maybe a little bit. They will be able to do more and more interesting things. There is a lot of resurgence at the moment of sort of on one hand you can call them the doomsday predictions. On the other hand, the singularity people do you believe something like AGI is imminent? Something, or let's call it human level AI. Do you think, because then all these questions pop up of ethics, of how do we treat machines that display the same level of intelligence? Are you generally in I want to say that the group of people who believe, yes, the acceleration is so drastic that it's really imminent, we're going to create intelligence, whatever that means? Or is it more the direction that says, well, it's a really good machine, but it's still like totally a machine?
I think this technology is extraordinary, and what we're seeing right now is the closest thing we've ever seen to general intelligence. And I think we're going to see a lot of progress over the next few years that pushes the limits even farther. So I'm very excited about the possibility. At the same time, I think that intelligence is generally a complicated topic. It's difficult to define. We often simplify it to a one-dimensional scale, like a test score, where one person has a higher score than another, and that means they're smarter. But in the real world, I don't believe that's how it really works. Intelligence is so multidimensional. There's 8 billion people on the planet, and there are so many different kinds of talents, so many different ways those talents are expressed. And also, it turns out that our value in this universe is not based on being the best at anything. I'm not the best person at anything. Out of the 8 billion people on the planet, there's always somebody that's better than me in every single aspect, every single dimension of my life. And yet, I'm still able to find meaning and purpose and able to contribute. And I think that that's going to remain true. So I generally don't like boiling everything down into a one-dimensional scale and starting to extrapolate what does that mean if we're all less than something else, because I just don't think that that's realistic. I don't think that's how the world has ever worked. At the same time, I do recognize that there are going to be some challenges that this technology poses, because every time there's been a new way of organizing human work, it has changed the ways that we think about ourselves and about what we do. And that is disruptive, and it could have the potential to hurt people. So I think that we need to be cautious about how we deploy this technology. We need to try to put safeguards around it. Honestly, I think OpenAI has been quite responsible. They have tried really hard to make ChatGPT safe to use, and it's not perfect, but they've, I think, done a really good job of making the technology better. I think we have more to go, and then I think we need to think about what are the implications of deploying this technology. I think that it's true that some kinds of work are going to be able to be solved by these models, and so some people are going to find that they have an opportunity to use their time hopefully in a different way, hopefully in a better way. I think generative AI is necessary in order to grow our economy as a worldwide civilization. We need tools. We need better tools for intellectual work, and that's what generative AI is better tools for understanding the problems that we need to solve, and then helping people get their work done more efficiently. And just as prior industrial revolutions have changed the way that people work, I think this one will as well. My grandfather could never have dreamed of me spending my life working in AI, because 70 years ago AI didn't exist. It just wouldn't have made any sense to him. And I think that is the normal progression of human civilization, is that as we grow, as we mature, we find new opportunities. And the things that we did in the past stay in the past. We change. It used to be that everyone or almost everyone was a farmer, and these days we are able to be dramatically more productive per person that's working in agriculture, and that I think has been a really good thing, because it has opened up possibilities for us to do something else. And that's what progress looks like. That's the only way that human civilization progresses, is by improving itself and becoming more productive. And AI is what we call the tools for making intellectual work more productive. So although I agree that there are challenges, and we need to be thoughtful and careful, and we need to try to take care of people, I also believe that this technology is foundational to our future.
Cool. Beautiful, beautiful words. We'll leave it at that. Bryan, thanks so much for talking to me, and invite everyone to come to your session.